Okay, I always try direct substitution first. This is for 11.2 in the pre-calculus course. If you do a direct substitution and you put a 2 in, I believe you get 0 over 0, right? So we have to use one of our techniques. One of them is factoring. So I'll factor a 2 out of the top, which will allow the x minus 2's to cancel. And I have the limit of 2 as x approaches 2. Since there is no x to replace, my answer is simply 2. Now that's for number 23. That'd be a factor cancel type. I'm trying to do at least one of each type. I think they wanted 27, which is, again, I believe if I put in 2, I get 0 over 0. You can try it. I've already done it. It gives you 0 over 0. So I'm going to try factoring. What can I take out of the first two? An x squared. What would that leave me with? X minus 2. Well, how about over here? Can I take a 4 out? Would that also leave me x minus 2? If you factor the x minus 2 out, what would remain? X squared plus 4. So that's how the top factors. Now let's factor the bottom. I'll use a different color. Split it. What can I, with 4 terms, no common factors, think about splitting it. Can you take an x to the third out of those? Would that leave me with x minus 2? Take a 1 out. A lot of people forget you can take a 1 out. That also leaves you with x minus 2. Factor the x minus 2's out, and what remains? X cubed plus 1. So I think I would have this, and when these canceled, I think I could put in what for the x? A 2? If I put in a 2, what's 2 squared plus 4? I think that's 8 on top. And putting in a 2, you have 2 to the third, which is 8 plus 1 is 9. So this result should be 8/9. It's a little harder to factor. Okay, number 29 on 11.2. Also, if you put in a 1, because x is approaching a 0. If you put in a 0, I believe it gives you 0 over 0. This one I see has radicals, so I have to think of conjugates. The conjugate of a minus b would become a plus b. So the conjugate of the radical minus 1 is going to be the radical plus 1. What is a minus b times a plus b? Well, it would become a squared minus b squared. If a is this radical and you square it, the radical goes away. Minus, if this is b, b squared would be 1. 1 minus 1 is 0, leaving the numerator with an x, which could cancel with the x in the denominator. Now I have something that I can put the 0 in for x. So now we're doing the limit as x approaches 0. If I put a 0 into there, I get 1 over 1 plus 1, or 1/2 for this result.
What's the little red part?
If you happen to have x plus 2 times x minus 2, you'd get x squared minus 4, the difference of squares. In general, you have a plus b times a minus b, which becomes a squared minus b squared. These are called conjugates. Can't spell conjugates. Okay? Conjugates. So basically this red part is the conjugate of the numerator. Instead of the radical minus 1, you use a radical plus 1. 39, whenever you see a fraction and a fraction, you need to think about the common denominators. My two denominators are 3 and x plus 3. So I'm going to multiply by 3 times the x plus 3. I hope everybody watches because this tends to confuse people. When I multiply here, the x plus 3's cancel, leaving me 1 times 3, which is 3. When I multiply here, the 3's cancel, leaving me x plus 3. However, you need to make sure you use parentheses. So, if I distribute and clean my numerator up, what do I get? 3 minus x minus 3. I think that simply leaves a negative x because 3 and a negative 3 add to 0. On bottom you have this. I believe the x's would cancel. And we're going to replace the x with whatever it says it's supposed to be, in this case a 0. So if I put in a 0 for that x, I get this, which I believe is negative 1/9. So if I put in a 2, I get 4 minus 4, which is 0, over 8 minus 8, which is 0. Always try direct substitution first. Because it gives you 0 over 0, then you might take one of the approaches. One of the techniques is factor cancel. So the top could factor to x plus 2 times x minus 2. Most people can factor the top. They have trouble with the bottom. The bottom's going to factor to x minus 2, x squared plus 2x plus 2 squared is 4. Now, these could now cancel. I would have x plus 2 over x squared plus 2x plus 4. And we want x to approach what value here? I think x is approaching a 2. So now I should be able to put in a 2, 2, 2, 2, and you have x plus 2 over that plus 2 times that plus 4. So I think that's 4 over 12, which simplifies to 1/3. Well, there's no radicals. That's why I didn't use a conjugate. There's no fractions and fractions, so I didn't use least common denominator. They were polynomials, so I decided to do the factor cancel method. I'm going to graph both of these. There's one on top I'll graph in purple. Oops, the one on top is y equals x plus 5, mx plus b. The y-intercept is 5, rise 1, run 1, and I believe you would have this line. Now, I only want it less than 1, so when x is 1, it comes up here and then becomes a open circle. But it does continue to the left. Now, this other one is x plus 7. It has a y-intercept of 7, rise 1, run 1. And I believe since the slopes are the same, these would be parallel. Now, I want it greater than or equal to 1, so I'm going to get rid of some of this other stuff over here. And I have my two graphs.
Is that supposed to be on the 7? Or like
I don't know. Is what's supposed to be on the 7? The 7 was if it was here.
okay.
But it's not there because I want it bigger than 1.
So it's like above 7.
It's at 8, I believe. If you put in 1 into 1 plus 7, you'd get an 8. Now, I need to know the limit from the left. So the little minus means from the left. What are these y values getting closer to? 6. From the right, which means a little positive means from the right. I want to approach 1 from the right. What are these y values getting closer to? 8. Because they approach different y values from the left and the right, the limit does not exist. It has to approach the same y value from the left and the right. Now, the way I usually teach it easier, other than graphing it, is just listen here a moment. If I looked at from the left, look at a number line. From the left, would that be less than or bigger than 1? Choose a value to the left of 1. Is it less than 1 or bigger than 1? So plug a 1 into there and you get out a 6. From the right, if I'm at the right of 1, is that bigger than 1? So plug a 1 into that one and you get a 8. So you don't necessarily have to graph them. Over here, this says to the left of 2. Would left be less than 2? Yes. Left is less than 2. So if you put a 2 into this one, I think you get a 9. Now this one with a little plus means from the right. From the right means bigger than 2. Think about where 2 is on a number line. Anything to the right of it is bigger than it, right? So plug a 2 in here. 2 to the third is 8 plus 1, which is 9. Does it approach the same y value from the left and right? If it does, that's the limit.